Module 3, Lesson 3. This section is called Rational Exponents. More or less, in this section, we are going to relate the exponential versions to their radical components. So we're going to begin actually with the examples. We're going to again skip the opening exercise. So in Lesson 3, we're going to actually begin on page 18 at the bottom half. It says example, and it says part A, what is the fourth root of 16? So that's the part that we're actually going to start on. And so this really just starts being with a square root idea, and they're going to relate the rational part in a few minutes. So we would start with this idea. We would say, what is the fourth root of 16? So it wants to come up with a number that if I multiplied it by itself, basically 4 times, that would be 16. So the answer ends up being 2. The reason why they call it the fourth root is because 2 times 2 times 2 times 2 is equal to 16, which is the same thing as saying 2 to the fourth power. And so again, our goal today is to be able to kind of relate this idea of this part right here to this part right here, and to be coming up with an idea of how they play out. So then they ask the next one, what is the cube root of 125? So they want to know what is the cube root of 125, and of course we know that answer to that is 5. That's because 5 times 5 times 5 is 125, which is the same thing as saying 5 to the third power. So then we want to know what is the fifth root of 100,000. And so that ends up just being 10. Right? And then for the same reason, you multiply 10 by itself 5 times, or it would be the same thing as 10 to the fifth power. Right, so they want this in exercise 1 to evaluate these pieces. So they want to know what is the fourth root of 81, and that would be 3. Right, same reason. 3 times 3 times 3 times 3 is equal to 81, which is also known as 3 to the fourth power. And then here we have what is the fifth root of 32. Again, that would be 2. Same reasons, 2 times 2 times 2 times 2 times 2 would equal 32. Since we got 5 2's, that would be saying like 2 to the fifth power. So here we have a product. Remember, if you have the same type of radical, which both have cube roots, we can multiply the numbers on the inside. So you get the cube root of 27, and thusly the cube root of 27 is 3. And then here we've got the same idea going, 125 times 100 times 4. And so that ends up being, oh no, not 125. Oh, okay. Let me make sure my book says something different. So it's 25. Right, it's not 125, it's 25. There we go. The fourth root of 25. So 25 times 100 times 4, that ends up being 10,000. So this is the fourth root of 10,000, and that ends up equaling 10. So that is exercise 1. So then the author in the book brings up this discussion, is if 2 to the 1/2 power equals the square root of 2, and if 2 to the 1/3 is the cube root of 2, then what does 2 to the 3/4 equals, right? So this is where the rule and understanding comes in. So let's emphasize this. We've got 2, it's raised to the 1/2, And they're going to tell us that this is equal to the square root of 2. So for visualizations, this 2 here is the 2 under the radical. The 2 in the denominator is the little 2 that would go right here with the square root. And this 1 in the numerator right here would go right here on that piece. Or it can go on the outside. So we'll put like a little or. It could be 2 to the square root of 2, and the whole thing can be raised to the first power. So it can go either way. Same idea. This 2 is, I'm going to color it red to match. This 2 would go here, and this 1 would be on the outside. So if that's the case, what they're asking us to do is to multiply these, or not to multiply, but if we take a look at this one, 2 to the 1/3 power. So I like this one better because you can see where the numbers go. So you got a cube root of a 3 and a 2. And so this 2 here matches this 2. This 3 matches this 3 here. And again, this 1, you can decide where you want to put it. Would be right there. Or you can put it on the outside. Doesn't really matter. So then they ask, what if we have 2 to the 3/4 power? What if we had 2 to the 3/4 power? What would that look like as a radical in that particular piece? That's what you're trying to think about. And to see if you can figure out where that's going to go. In that perspective, I'm going to do a little calculation for curiosity's sakes. Right, so we rewrite this, we think about what we learned, look at the color codes here. So we would put the 4th root of 2, and you put a 3 here. Or you could write it as the 4th root of 2, and you can raise it to the 3rd power on the outside. But again, just for color emphasis, you could see this matches with this one. The 4, which is in the denominator of my fraction, becomes what my root is going to be. And then my numerator in my fraction becomes the exponent of the base either inside the radical or the exponent of the piece overall. Which one you use is really up to you. I like this one better. That is just my preference. But they are both the same, and they are equal in that perspective. So then they bring up some exercises. They just want us to rewrite each exponential expression as a radical expression. And so if we take a look at some of these, right, 3 to the 1/2 power, that would be equal to the square root of 3. You don't have to put the little 2 for square roots. That's really optional. This one would be the 5th root of 11. This one would be the 5th root of 1/4. This one would be the 10th root of 6. Right? So this one, notice now we're talking about 2 different numbers besides a 1. So this would be the square root of 2 to the 3rd power. Now they say in these, if the number is rational, write it without radicals or exponents if possible. So this would bring up those exponent rules we did at the beginning of the year. So 2 to the 3rd power 2 times 2 times 2 is 8. So, right, so if you remember, we could break this up into a 4 and a 2. And so the square root of 4 is 2, so we went to 2 square roots of 2. So really they want us to simplify these. So we'll add a little note, dot, dot, dot. Their goal is to have us simplify these if possible. So in the next one, right, you get equals the square root of 4 to the 5th power, right? Remember, in this case, it might be smarter to take this one. Remember, I showed you in the previous set of slides, there's an or. Let's not do this. Let's see, or is what I'm trying to write. I can write it as the square root of 4 to the 5th power. Now again, this is about making a choice, right? If I leave this inside, I'm going to have to find 4 to the 5th power. Or, if I write 5 to the outside, I know what the square root of 4 is. The square root of 4 is 2. And now I got to just go do 2 to the 5th power, which we did a little while ago. And so we get that answer of 32. That is why it's important to know both ways to write it and simplify it out as appropriate. So the letter number 8, this would be the cube root. The cube root of 1/8, and then we'll put a 5 on the outside. Because I know the cube root of 8. The cube root of 8 is 2. So the cube root of 1/8 is going to be 1/2. And we raise that to the 5th power. So 1 to the 5th power is still 1. And 2 to the 5th power is 32. Number 9 says they want us to show that the following statement is true. Remember, this is just the understanding that you could change your exponents. So if I've got 2 to the negative 1/2 on this side, and this is currently in the denominator, I can move it to the numerator. And hence, they are exactly the same. So there's nothing to really focus on in that perspective. So in number 10, they ask us to rewrite each exponential expression as a radical expression. If the number is rational, simplify the radical as appropriate. So we'll take a look at this and see what we can do. Here we have a negative exponent, so let me emphasize that. If we don't want that negative exponent, we're going to move it to the denominator. So 4 3/2. Now I have a positive exponent. And so it's going to be the square root of 4. And because 4 is a perfect square, I'm going to put that 3 on the outside as opposed to the inside. So the square root of 4 ends up being 2. So now we get 2 to the 3rd power. And 2 to the 3rd power is 1/8. Right, same thing with this one here. It is currently a negative exponent, so we're going to move it to the denominator. That makes my exponent positive. So again, we're going to rewrite this. This is going to be the cube root of 27. Because I know the cube root of 27, I'm going to leave my 2 on the outside and take this cube. So that ends up being a 3. So 1 over 3 squared now. And we simplify to 1/9. So same idea with each of these in that perspective. Nothing really changes in that design. So we're going to omit number 12 for confusion's sakes and not worry about number 12, I think. I don't believe I'm going to be assigning anything like that, but maybe we will. I'm not real sure. in that design. I guess we can look at it, right? It's not going to be that big of a deal. So if we apply the same idea, we move this to the denominator. So this becomes 1/4 with a square root. Actually, we'll write it like this first. 1/4 raised to the 1/2 power. So once we have that, right, we're going to now take the square root of 1/4, and that ends up equaling 1/1/2. And so 1 divided by 1/2 ends up being a 2. So now that ends the given lesson. There is a lesson summary at the end of this lesson if you wanted to be able to see these particular rules that we put into place. Other than that, that would be the end of lesson 3.